Hi, this is Dr. Green, and we are looking at some examples for homework set number 3 for Math 111. So in this first problem here, they want us to give the domain and range for this relation and then describe whether or not it's a function. So the domain here is just the set of all the first coordinates, the x coordinates, and if we do them in order, I guess that would be 0, 2, 3, and 5. So your domain, let's give us a little bit more room here. Your domain is going to be the set 0, 2, 3, 5. And then the range is the set of all the second coordinates here, which is going to be -1, 0, 1, and 5. And then they want to know, is that a function? So does every x have exactly one y? So 2 is paired with 1 and nothing else. 3 is paired with 0 and nothing else. 0 is paired with -1 and nothing else. 5 is only paired with 5. So each x has only one y. So yes, it is a function. Each x, or each first coordinate, has only one y, or only one second coordinate. And that's what makes it a function. In number 2 here, we're using the coordinate template to draw the graph of the square root functions for f and g in the same coordinate system, and then we're going to use integer values of x and obtain ordered pairs. And then once functions are graphed, we're describing the relationship between the two. So our function f is root x, and we're going to use the values 0, 1, 4, and 9. Our function g is root x minus 3, again using x's 0, 1, 4, and 9 to graph. So I made a table here for f, my x value 0, 1, 4, and 9, and then my equation f of x is root x, and then my ordered pairs. So f of 0 is square root of 0, which is 0. So that means x is 0, y is 0. That's ordered pair 0, 0. When x is 1, then the y value, f of 1 is square root of 1, which is 1. So our ordered pair is 1, 1 right here. And then x is 4, so f of 4 is square root of 4, which is 2. So x is 4, y is 2, 4 comma 2 there. If x is 9, f of 9 is square root of 9, which is 3. So we get x is 9, y is 3, 9 comma 3 there. And then I did the same thing down here with the function g of x is root x minus 3. It's just subtracting 3 from each one of these y values up here. So for x is 0, 1, 4, and 9, g of 0 is square root of 0 minus 3. So that's 0 minus 3, negative 3. So x is 0, y is negative 3. 0 comma negative 3. When x is 1, g of 1 is square root of 1 minus 3, which is 1 minus 3, negative 2. And so that gives us x is 1, y is negative 2, 0.1 comma negative 2. When x is 4, g of 4 is square root of 4 minus 3, root 4 is 2, minus 3 is negative 1. So x is 4, y is negative 1, 4 comma negative 1. When x is 9 here, we get root 9 minus 3, 3 minus 3, that's 0. So x is 9, y is 0, 9 comma 0. So now we can graph these ordered pairs and play dot to dot here. So 0, 0 for f right here. 1, 1, so 1 to the right, 1 up right there. 4, 2, so 4 to the right, 2 up right here. And then 9 comma 3, 9 to the right and 3 up right there, and then this graph is going through. So that is the graph of f of x is square root of x. And then down here, 0, negative 3 right here, 1, negative 2, 1 to the right, 2 down right there, 4, negative 1, 4 to the right, down 1 right here, and then 9, 0, 9 to the right, 0 up and down right there, and then we connected those. And that is our g of x, which is root x minus 3. And then they want to know what's the relationship between these graphs, and the graph of g of x is the graph of f of x, and everything is shifted down 3 units. So it's the graph of f of x equals root x shifted down 3. So you can tell here from 0 down to -3, from 1 down to -2, all of these guys are going down 3 units. And that's this -3 that's on the end of the equation. Remember, numbers that are added or subtracted are up-down shifts, positive are up shifts, and negative are down shifts. So that's translating that graph down 3 units. And then number 3, we want to evaluate this graph and determine if y is a function of x. And remember, one way to do this is to do the vertical line test. So if a vertical line hits any place more than once, and there's lots of places where it hits more than once, then the graph is not a function. So for example, at x equals 4, you hit the graph here and here with a vertical line. So that means that x value of 4 has 2 y values that go with it. That y value up there, and then also this y value down here. So you've got one x value with 2 different y values, not a function. So that one's not a function. It fails the vertical line test. And in number 4, we're using the graph below. That's this graph right here to determine the function's domain. So that's all possible x values. Well, this graph stretches, keeps going to the left, and then keeps going to the right. So our domain is going to be all real numbers, or -infinity to infinity. We use interval notation. The range, the y values that are hit, well, the smallest y value that's hit here is at -2. And then every y value above there, you could go over and hit the graph. So those range values get covered by the graph. So the lowest value is 2, and then anything that's bigger. So from 2 up to infinity, and close bracket at 2 because we're including. X-intercepts. So you got 2 x-intercepts. That's where it hits the x-axis here at 4. And then right here, it looks like maybe 1.6 approximately. So 1.6 and 4. Y-intercepts, where it hits the y-axis. So it looks like we hit the y-axis right here. So it looks like that could be about maybe 1.8, 1.7, 1.8. And then the function's values f of 2 and f of 4. So f at 2, so we start at x equals 2, and we go down here and across, and y is equal to -2. So f of 2 is equal to -2. And then f of 4, so at 4, you don't go up or down at all. The function value is at 0. So f of 4 is equal to 0. So you just start from that x value and either go up or down, whichever way hits the function, and over, and that finds your function value. And let's see, number 5, we're using the graph to determine intervals where the function is increasing. So that means it goes up from left to right. So it looks like up to x values of 2 here, it's increasing. And then looks like from approximately from 4 on, it's increasing. So from -infinity up to 2, on that interval, it's going up from left to right. And then also the interval starting at 4 and going all the way to the right out to infinity. So that's where it's increasing. Decreasing is down left to right, and it looks like it's going down left to right between 2 and 4. So that would be the interval from 2 to 4. Intervals on which the function's constant. So constant means horizontal. There aren't any intervals here where it's horizontal, because it increases, decreases, and then increases again. Constant function would have to look something like this. It would come up, and then you'd have a horizontal section, and then it might keep going up, for example. So it would be constant on that interval there, which would be this x value to that one. Don't have that going with this function. We're looking at graphs here for symmetry, and then to determine whether the graph is even or odd. So remember that even graphs are y-axis symmetry and odd graphs have origin symmetry. So for graph A here, this has got origin symmetry. If you rotate it around the origin 180 degrees, then you get the same graph again. So you've got rotation symmetry around the origin. So here we've got origin symmetry. And remember, when you have origin symmetry, that means that the function is odd. Remember, odd functions are ones where f plug in negative x is the negative of f of x. So in other words, here, for example, we're at 1, and our function value is down here. But if you did -1, your function value would be the opposite. Whatever this is below, this is above. Another way to look at origin symmetry is if you go through the origin, on the other side there's a corresponding point. So these 2 points correspond. And then B has y-axis symmetry. And y-axis symmetry tells you that it's an even function. And remember, even functions are ones where f plug in negative x is the same as f plug in x. So for example, f plug in -2 here. Looks like we're at -1. F plug in +2. We're at that same -1. It happens for every 2 points that are same distance on each side of 0. And here we're using the graph below, this graph, to find each of the following using interval notation where it is needed. So domain of the function. So, well, this keeps going to the left and this keeps going to the right, so our domain's going to be -infinity to infinity. Nothing that gets ruled out there. No open circles on the graph, no asymptotes. Range of f. Looks like there's a highest point here at 2, but all the y values below, you can either go to the left or go to the right and find a point that goes with it. So range would be from -infinity up to 2, and including 2, so a square bracket there. X-intercepts, looks like we got an x-intercept here at about -2.6. And then we got another x-intercept here where it hits the x-axis, intercepts the axis at x = 3. Y-intercept, got a y-intercept right here at a height of y = 1, so that's where it's the y-axis right there. So that's 1. Intervals where f is increasing, so it's increasing up to an x value of -2, and then between x is 0 and x is 1. So this would be -infinity up to -2. And then also from 0 to 1. And then decreasing, so a function goes down left to right from 1 on. So that could be from 1 to infinity. And then intervals where the function's constant, well, it's horizontal constant here between -2 and 0. So -2, 0. A number at which f has a relative maximum, so that's a highest point, and that happens at x = 1 here. So x = 1. And then the value of the relative maximum is the y value, which corresponds to y = 2. Or f of x = 2. F plug in -1. So if you go from -1 up to the graph of the function and over, you're at height 1. So f of -1 is 1. Values of x for which f of x is -2. So let's see here. So we go over here and up. It looks like x is -3. Okay, so x is equal to -3, so we can tell that one on that side. And then there's another one over here. This keeps going down, but we can't tell what the x value is. So -3 we know for sure. And then is f even, odd, or neither? Well, this does not have left-right symmetry, no y-axis symmetry. It's not reflection over y-axis, and it's also not rotational symmetry around the origin. So this is neither. And then these line graphs here are showing the weight for adult women and men as they age from range 10 to age 70. And we're using those graphs to answer following questions. So intervals on which the graph giving the weight of women is increasing and decreasing. So it looks like women, looks like this goes up left to right to about 50. So from age 10 to age 50 it's increasing, and then decreasing from 50 to 70. So you're gaining some weight, and then you get a little bit older, and you know, as people get older, sometimes they eat less, and even though your metabolism's slowing down. So increasing here would be from age 10 for women to age 50, and then decreasing from 50 to 70. And then for what age does the weight of men reach a maximum? So the highest point on the graph for men is here, and that is at an age of 40. And then what is the weight for that age? Okay, so for what age? So age 40. And then the weight, we would go across from the 40 here, about right there. And that looks like that's maybe, I don't know, maybe 180? Because this is 150, 175, 180, maybe 190. So I would say approximately 190. 190 pounds. There's some room for estimation there. Find slope of the line passing through these points and indicate whether the line rises, falls, or horizontal or vertical. Okay, so we can label these points here x1 and y1 and x2 and y2. So first x, first y, second x, second y. And then your slope, remember, is the difference in the y's, y2 minus y1, over difference in those x's, x2 minus x1. So second y minus first y, 1 minus 2, over second x minus first x, 5 minus -3. So 1 minus 2, -1. 5 minus -3, 5 plus 3, 8. So that's a -1/8 is our slope. That is less than 0. Okay, so less than 0 slope is a line that falls from left to right. So it's going to be going down left to right like that. So this one falls. And positive slope would be rises, 0 slopes horizontal, undefined slope vertical. And here we've got a slope of line 5, goes through the point 1, -2, let's call that x1, y1. And we're going to write the equation for the line in point slope form and also slope intercept. So point slope form, remember, is y minus y1 equals m times x minus x1. So our m is right here. Slope is 5, so m equals 5. And here's our x1 and y1. So we can just plug those in. So y minus y1 is -2, y minus -2 equals m is 5 times x minus x1, so x minus 1. So there's our equation in point slope form. And slope-intercept, you just solve for y. So this will be y plus 2, double negative makes a positive. Multiply the 5 in. So that'll be 5x minus 5. Bring this 2 over as a negative. So y is going to be 5x minus 5 and minus another 2, 5x minus 7. And there's your slope-intercept form. Okay, let's see. Number 11, give the slope and y-intercept of the line, whose equation is f of x is -2/3 x plus 1, and then graph. Okay, so our slope is the coefficient of the x, which is the -2/3. And then the y-intercept is on the end there, so plus 1. And then to graph that, start from your y-intercept, so that's 1 on the y-axis. And then our slope is -2/3, which is rise over run. So we are going to fall 2 and run 3 to get the second point. So down 1, 2, run 1, 2, 3. There's our second point for the line. And now we can go ahead and we can graph that line like this. And there's our line. So it's always start from the y-intercept point and then rise or fall and then run. And here from this graph, we want to list the slopes of these lines here. So they all have form y equals mx plus b in decreasing size. So that would be from positive to negative. So the two, let's see, this is the only positive line. It goes up from left to right. So M1 is going to be the biggest slope. So M1 is first. So that one's set. And then this is horizontal slope, so that's 0. And then these two go down from left to right. Those are negative slopes. So 0 slope is going to be the next one. That's M3. And then these two are negative slopes. This one is steeper negative, so that's going to be more negative. So let's see, so we did this one. So the shallower slope, that's going to be less negative. That looks like maybe fall 1, run 2, maybe -1/2. So M2 is going to be next. And then this one is steeper. This looks like this is maybe fall 2 and run 1, maybe a slope of -2. So that one's set, and then slope 4 is going to be the most negative. So this one is positive, 0, negative, and more negative. Write an equation for the line L, that's this line here, in point slope form and slope intercept form. So we're given this line y equal 2x and L is parallel. Okay, so what we know is that, well, the slope of this line is m equals 2. So our given line has slope 2. And then the line that we want, L, that's going to also have slope 2. Okay, so our parallel slope is going to be equal to 2. And then it goes through this point 1, -1. Well, that's going to be our x1, y1 in the point slope equation. So now we've got x1, y1 is equal to 1, -1. And so our y minus y1 is m times x minus x1. And so this will be y minus y1 is -1 equals m is 2 times x minus x1 is 1. So that's our point slope equation. So this is point slope. And now solve it for y, and you'll have your mx plus b, your slope-intercept. So double negative makes a positive. Y plus 1 is equal to 2 times x is 2x. 2 times negative 1 minus 2. And then subtract 1 on both sides. And we get y equals 2x minus 3. And there is our slope-intercept. And if instead of doing the parallel line, if they did the perpendicular line, remember here that the perpendicular slope is the negative reciprocal. So that's negative 1/2 in this case. So that's the only thing that would change, is you'd use a negative 1/2 slope if they wanted the perpendicular line. 14, we want a average rate of change, which is a slope for our function 2x squared minus 3x from x1 is 1 to x2 is 4. So your average rate of change here is going to be the function value at 4 minus the function value at 1, and you'll divide by 4 minus 1. So if we plug the 4 in here, 2 times 4 squared minus 3 times 4, and then minus, plug in 1 here and here, 2 times 1 squared minus 3 times 1. And then we are dividing by 4 minus 1, which is 3. So let's see, this is 16. 32 minus 12 is 20. Minus 2 times 1 is 2, minus 3, negative 1. And then divide by 3, and that's 21 over 3, which is 7. So you got our average rate of change for that function is 7. And up next, we are writing the equation in slope-intercept form for a linear function whose graph satisfies the conditions that it passes through the point 4, negative 2. So that's an x1 and a y1, and is perpendicular to the line that has x-intercept 1 and y-intercept 2. Okay, so first we need the slope of this line that's got x-intercept of negative 1 and y-intercept of 2. So x-intercept of negative 1 means it goes through the point negative 1 comma 0. And then y-intercept 2 means it goes through the point 0 comma 2. So then the slope of that line is going to be y2 minus y1, 2 minus 0, over x2 minus x1, 0 minus negative 1, which is 2 over 1, which is 2. So that is our given slope. And then the perpendicular slope then, so the slope of the line that we want that's perpendicular is the negative reciprocal. So that's negative 1/2. And now we got our x1, y1, and we can go ahead and plug into y minus y1 is m times x minus x1. So we can do that, or we can plug into y equals mx plus b. Now we can plug in here our m and our x1, y1, and then solve for y to get the slope-intercept, or we can plug directly in here. A lot of students like to do that, so let's plug our negative 1/2 slope in there. So y equals negative 1/2 x plus b, and then we just need to find our b, and the way we do that is we know that this point's on the line, so it has to work in the equation. So plug in y is negative 2 and x is 4. So negative 2 is equal to negative 1/2 times 4 plus b. Negative 1/2 times 4 is negative 2. So negative 2 equals negative 2 plus b. And then add 2 on both sides. So these negative 2's will actually cancel off and you get b equals 0. So then we can plug that in here, and our line is just y equals negative 1/2 x plus a 0, which we don't have to write. It's just y equals negative 1/2 x. And you'll get that same thing if you use the point slope equation too. And let's see, number 16 here, we're looking at this graph that describes the age at which Americans are getting married from 1970 to 2010, every 10 years. And we want to know, we want to find a linear function in slope-intercept mx plus b form that models the data. Function should model the marrying age f of x by Americans x years after 1970. So that's saying that x equals 0 corresponds to 1970 in our equation. So this is x equals 0, this is x equals 10, so look at the year here, and then the x value. X equals 20, and 30, and 40. So the easiest way to do this is to take our first point and our last point, and then generate the line from that. So we've got our x values and our y values here. So when x is 0, the age is 22.4, so 0, 22.4. When x is 40, age is 27.2. So people waiting longer to get married. So we've got a first x here and a first y. And we've got a second x and a second y. So now we can compute our slope, which is y2 minus y1. So we subtract these guys. 27.2 minus 22.4 over x2 minus x1, 40 minus 0. And if you compute this on the calculator, you actually get a nice answer. On the top, this difference is 4.8. Divide by 40 on the bottom, you get 0.12 as your slope. So now you know y equals 0.12x plus b. That's mx plus b. And then we know what our y-intercept is here. The y-intercept is the y-coordinate when x is 0. Well, when x is 0, y is 22.4. So that's what the b is. So this is 0.12x plus 22.4, where x is years after 1970. So that's, again, using this point and this one, okay, which is our best estimate used for average rate of change. So that's that line in relation to the data. So just use the first and last point. Okay, number 17, we're looking at translations of graphs here. So this is the graph of y equals f of x here, this V-shaped graph. And we want to do the graph of g of x is f of x minus 2 minus 1. And we're using a coordinate axes here to draw. So here we subtracted 2 on the inside, and remember here that the inside of the function, when anything's done on the inside of the function's a liar. It does the opposite of what you think. So if you are subtracting 2 on the inside, that's going to add 2 to the x coordinate. So this is 2 to the right, shifts the graph 2 to the right. And then the outside, what's going on outside the function, they're telling the truth. So this subtract 1 from the g of x value, the y value, is shifting the function down 1. So we want to shift this function to the right 2 and down 1. So take this point and go to the right 2 and down 1 right there. And then we only need, 2 other points. So for example, this point here, to the right 2, down 1. And then we could take this other intercept point here to the right 2 and down 1 right there. And so let me use different color to draw our other graph here. So the blue graph is the shifted. Okay, so this is our function g of x, which is f of x minus 2 minus 1. And then in 18 here, we're given y equal f of x. This is the graph of f of x here. And we're going to graph g of x is 2 f of 3x. And again, on the same coordinate axes. So remember, multiplications outside here are stretching factors. So this is a vertical stretch times 2. So that's by a factor of 2. And then on the inside, remember the inside's a liar, so it does the opposite of what you think. You're multiplying by x by 3, so you're thinking, oh, that's going to stretch, but it's not. It's a compress. This compresses by a factor of 3. Okay, so it compresses times 1/3, so it's only 1/3 as wide. So instead of this point going over from 0 over to 6, it's only going to go from 0 over to 2. Okay, because you're horizontally, you compress it to 1/3 of the size. And then this one, instead of going over to 3, it's only going to go over to 1. It's only going to go over here. But you've got a vertical stretch times 2. So it's going to be 1/3 as wide, but it's going to be twice as high. So it's going to go up to 4 instead of up to 2. And then this point here, instead of going to -6, it's going to go to -2, 1/3 of the way. Okay, that's your horizontal compression. And then this one, instead of going over to -3, we're only going to go over to -1 there. But then we've got a vertical stretch times 2. So instead of going down to -2, 2 times -2 is going to go down to -4 there. Now the reason that these 2 points don't move up and down, they stay on the axis, is because the y-coordinate here is 0, and 2 times 0 is still 0. And then the same thing here, this stays at 0. So then that gives us our graph of our function. Looks like this. So connect the dots here. And there's our function. And you can see, instead of going from -6 to 6, instead of having a width of 12 here, it's got a width of 4, which is 1/3 as much. So that's compressed times 1/3. And then the height here, instead of going from 0 to 2, it's a height of 4, which is twice as high. And that's the vertical stretch times 2. So just remember, the inside's a liar. It does the opposite of what you would think. And 19 here, we're given graph of y equal x squared right here. And we want to use transformations to do x plus 3 squared minus 2. So again, here we added 3 on the inside, but the inside's a liar, so it does the opposite of what you think. Instead of adding 3, instead of going to the right 3, it's going to go to the left 3. So plus 3 on the inside, that shifts us to the left 3. But then subtracting 2 on the outside, that's up-down shift, and that does what you think. Negative is down, positive is up. So this is down 2. So we're going to take this whole graph, shift it left 3 and down 2. So this point here goes left 1, 2, 3, down 1, 2, right there is our vertex. This one will go to the left 1, 2, 3, down 1, 2, right there. And this guy, 1, 2, 3 to the left, down 1, 2, right there. So you can see that our transformed function looks like this. Okay, whole thing goes to the left 3, down 2. Alright, and then last one, f of x is 3.5 root x plus 10.5, and that model describes the height here, f of x in inches of a tree that is x years old. And then the graph is shown down here. And what they want us to do is describe how this graph can be obtained using transformations from just the square root function. Okay, well, this outside multiplication is a vertical stretch times 3.5. Okay, so vertical stretch times 3.5. And then the plus 10.5 on the outside shifts it up 10.5 units. So stretch it vertically by a factor of 3.5, shift it up 10.5, and you'll have your square root function. Well, I'm sorry, you'll have this function from the square root function. Use the model to find the average rate of change. That's going to be a slope in inches per year between 0 and 2 years. So between 0 is that point right there, and 2 is this point right here. And we are going to be finding the slope of the secant line. That's your average rate of change, is the slope of the secant, just like that. So that slope is going to be the function value at 2 minus the function value at 1. I'm sorry, 0. And then divide by 2 minus 0. So the function value plug in 2. So we're just going to plug in 2 to our function here, which is actually square root of x. Right? This is 3.5 times square root of x. Actually, let's see here. No, yeah, that's this f of x. Yeah. And so plug a 2 in right here. So you're going to have 3.5 times square root of 2 plus 10.5. And then subtract off 3.5 square root of 0 plus 10.5. And then we're dividing by 2 minus 0, which is 2. And then 3.5 times 0, that's just 0. And then we've got a positive 10.5 and a negative 10.5. These guys just cancel off. So we're just doing 3.5 times root 2, and then divide that by 2. And then round this to the, let's see, given, yeah, nearest 10th here. Round that to the nearest 10th. So I rounded that to the nearest 10th, and I got 2.5. Just 2.5 inches per year. So over this time period, trees growing 2.5 inches per year. And then from 5 to 8, okay, so from 5 to 8 is going to be the slope of this secant line, which looks like it's almost the same as the graph, but there's a little bit of curving in the graph. So that's going to be almost the same thing. So we're doing another slope here. It's going to be f of 8 minus function value of 5 divided by 8 minus 5. So plug 8 into the original function here, so that's going to be 3.5 square root of 8 plus 10.5, and then minus 3.5 square root of 5 plus 10.5, and then divide by 8 minus 5, which is 3. And I did that one on the calculator, and I got approximately 0.7 inches per year. And so that's part C. So this is actually part B, and this is part C. Use the model to find average rate of change 5 to 8, round to the nearest 10th. How does this compare to your answer in part B? So it's smaller. So 0.7 is less than 2.5. And then how is this different shown on the graph? Well, the slope is shallower. This is a steeper slope. Okay, so the slower growth means a shallower slope. Faster growth is a steeper slope. So we could just say here that faster growth corresponds to a steeper slope. That's what they're looking for there. All right, so you should be able to do all of the homework problems. They should be very similar to this. And then the quiz problems are variations that are also similar to these problems.